all the classrooms at Heritage High School have desks that are in groups. Is that a true statement? Okay. Can someone give me a counterexample? A counterexample, Jack?
Like, all the desks are separate, like in rows.
Okay, but can you give me a specific case that shows that my conjecture that I just made is false? I just said all the classrooms in Heritage High School have desks in groups. Can anyone give me a specific example that proves my statement false? An example that proves what I just said, that all the classrooms in Heritage High School have desks that are in groups. False. Anybody? Okay. Joey?
L202 has them in a U.
Oh, okay. So the room right below mine has the desks in a U. That's definitely not a classroom that's got desks in groups, right? What's another counterexample to that? Yep. PE doesn't have desks in groups, right? It's technically a classroom. I mean, I'm sure you've been in a classroom where all the desks are facing forward when you have to take a test or something, right? Okay, so that's what a conjecture is. It's an unproven statement that's based on an observation. Okay, we don't know what's true. We just make an observation, then we make a statement. It could be false, it could be true. But a counterexample is what's really important here. It's a specific case that shows that that original statement is false. So I've got an example on a slide here. We're going to see one of the things we have to make sure we know how to do is give an example of a counterexample. So let's see. That's making a conjecture. Here we go. Slide number 5. If y is in between the points x and z, then y is the midpoint. Okay, that's a conjecture, and we're going to see if we can give a counterexample. The only time we ever need a counterexample is if the statement is false. Obviously I gave you a false statement because we're trying to understand what a counterexample is. If the statement's true, then we don't need a counterexample because it's true all the time. If y is in between points x and z, so here's x and here's z, and y is in between, then y is the midpoint. Okay. First of all, is that a true statement? Does y have to be perfectly in the center? It could be anywhere, right? So I'm gonna put it right here. Because there, y is in between x and z, but it's not the midpoint. So draw the diagram, make sure to label the points. So there we go. Okay, so a counterexample would be x is 1 inch away from y and y is 3 inches away from z. Okay, it's not directly in the middle. So let's go ahead and write that down, and I'm going to stop the video on counterexamples.